All right, good morning. Let's look at types and casting and fun things like that. The first thing I want to talk about is that you remember that computers treat everything as numbers. And it's no different whether you're talking about a string or you're talking about an integer, some of the data types that we talked about in Snap. Let's take a look at this. This is an ASCII chart. And an ASCII chart is the way that we can map letters. You'll see them over here. We've got the alphabet. We've got it in uppercase. We've got it in lowercase. And if we look over here, we can see that we've got the numbers that they belong to. So we've got decimal in this first column. Hexadecimal is a way of writing things in shorthand, the way a computer looks at it. Let's just worry about these decimal numbers here. So if I wanted to say good morning to you, a computer needs to know a number. And if I started to say good morning with a capital G, the number that it looks at first is 71. So let's look at that right here. And you'll notice there's 71 on the left and there's a G on the right. If a computer gets a 71, it doesn't know what to do with it. What it needs to do is to have it in a box saying what it is. What is the 71? Should I treat this as the number 71 or should I treat this as the letter G? And so the box that 71 gets dropped into has its type. And in this case, the type would be a character, just a single letter. So if we're going to do good morning, we could come over here and let's say that the next one, we're not going to scream good morning, so the next one's going to be lowercase. And here we have an O, and an O goes to decimal 111. So if you see in a box that says 71 as a character, and then you add it to a box that says 111, which is also supposed to be a character, we'll have G plus O, and so far we have go, and we're well on our way to good morning. If you want to do arithmetic, you would add 71 and 111 if the boxes that those were put in weren't characters, but said, hey, this is an integer, this is a number. You add them together and you get, what, 182. Does that make sense? That's the quick version of what we're learning today. So if you look at our do now, we wanted to open up the console and start writing this code. And then we'll ask a couple of questions about different types. So let's take a look. I've got that over here already. We've got a couple of variables. We've got stage 1 of X. We've got stage 2 of Y. And we start off with 123 and 456. Then we put it into stage 2. And to do that, we're calling this function str. That is going to turn whatever is in here, if it can turn it into a string, it is going to turn it into a string. And remember, when we print things to the console over here, we're going to print strings. So the box that we're putting the numbers in this case a long list of numbers, is going to let the computer know that we're looking at a string. And so when it gets the number, it's not going to add these together as if they were actual numbers. The box that 123 is put into for X underscore stage 1 says I'm an integer. You can pick that up by just knowing that 123 is an integer. And here, though, when it turns into a string, now it does 123, puts it into a different box through that function, and X stage 2 knows that we've got a string. So let's go ahead and run it. We've got these two things that are integers, and then we have them put into new variables, which are strings, and then we're going to add them together, and let's see what happens. So we've got 1, 2, 3, 4, 5, 6. And that's not added together with arithmetic. It's added together as if those were two strings of letters, or digits in this case, right? As if we were using magnets on our refrigerator or something, and we've put those things together, and that's what the answer looks like. Now let's see if it, for the next step, let's see if the stage 1 stuff behaves like we'd expect. So let's do the same thing we were doing here, but let's take the values before they got cast into strings. Let's run that. So first we'll see what we had here, and now we're going to see the stage 1 added to the stage 2, and sure enough, we've got real arithmetic here. We haven't cast it from a number into a string. These are still numbers. So that's good. So you understand where those come from, I think, right? So we've got 123 plus 456 is 579. What we're basically learning is the same lesson that we had earlier in Unit 1, which was with these cats. You remember in Snap, if we join the 1 and 2 as if they were strings, then we get 12. If we say 1 plus, so what's happening in the green is we're treating them as numbers in this case, then we get 3, right? The difference is Snap used JavaScript, and JavaScript is always going to try to take a type and figure out a way to put them together. Python's a little different. If JavaScript, or Snap in this case, has two boxes of different types, one's an integer or a number, and one is a string, which is a value to print out, and tries to put it together, it's going to cast one to the other as well as it can. And Python's going to blow up. So let's take a look at that. So let's put a nice label in front of, and so we have a string, you can tell because I've got quotes around it. And let's put a label before what comes here and here. So we're probably going to get this, and we want to put a nice label so that we know what we're looking at. Since we have two things here, we've got stage 2 first, and we've got stage 1 second. That might be confusing. Let's add a label. So here we are. We've added a string, and we've added both of these stage 2 values, which, again, remember, have been turned into a string through casting. Casting means you very specifically, it's almost like when you cast something in metal, and you take something, the metal is malleable, you stick into a cast and it cools down, and now it looks like what that new cast told it to look like. So we've got stage 2, and we've got the value after it. Now let's try to put a label on stage 1. So these are the things before casting them from numbers to strings. Oh, now we got a problem, right? So we've got a traceback on line 27, right here, the thing we just uncommented. We've got a problem. You can only concatenate or add together strings, not ints, if you want to print out a string. So here we've got two ints. Remember, the box that the number is in says I'm a number. And so now we're trying to add a number to a label, and Python says I can't do that. Okay, Snap would try, and it does weird things that we saw earlier in the semester. But this, no bueno, right? So let's take this out. So how would we fix that? Well, we'll look at that in just a second. Here are the specific questions from the do now. So here's our do now. Here are our questions. Let's go over them quickly. What are the variables x stage 1 and y stage 1? What type are those? So you can guess, and we've already talked about them. They're integers to begin with. But we can also print them out by using this. We can ask the interpreter and use this function type and figure out exactly what they are. So let's print it. Remember, we took out the thing that was blowing up. And now we can see both of those are, or x underscore stage 1 is of class int, which stands for integer. And just for fun, let's find out what the stage 2 variable is. Now, if you look, what I'm doing is I'm adding a label to it. But to do that, this type function returns a type. It's actually not a string. One of the neat things that this print does is tries to figure out what's inside of it. And as long as it's consistent, it will turn it into a string. But if you add a string to something inside before you call the function, they have to be the same in Python. So here's our label, and there's a string. We're turning the type of x underscore stage 2 into a string to add with the label. Does that make sense? So if I took this label away, what would happen? Actually, we'd be okay. But if I didn't take this away, if I just took the string cast away, and now I try to run it, now I've got a string here, and my type of this, the box that it's in, is of type. So that's tres meta. And we blow up. Does that make sense? So to be able to add two strings together before passing them to the print function, I'm going to need to cast again. I'm going to need to take it, turn it into that metal, put it into the cast, and make it look like something else. And there we are. What type of the variables x stage 2 and x? Well, we just answered that already. How would you convert a string, 100, to an integer? Now, this is sort of a trick question, right? But the reason you're worried about that is when you ask for a value from the user, you're going to ask for it with the input, and input's going to give you a string. It's not going to be a number, even if what they enter looks like a number. So here's a guess. If str x turns x into a string, why don't we see if int y turns y into an int? See if we get lucky. So I've got 100 as a string, and let's try to print out the int. Well, it's got 100 there, but that doesn't really prove much, right? That could be a string, that could be almost anything. So let's do some arithmetic with it. Let's take the int from the string 100, and let's add 50 to it. There you go, now we have 150. So the idea would be, if I tried to do print 100 plus 50, it'd be exactly what we had before, right? Where we had the trouble where we're trying to add a string to an int, and it should blow up. So there we go. So the box, Python again, Python's not going to look what's in the box. Python just says, hey, this box tells me it's a string, and now you're trying to add it to a box that says it's an int. I can't do these two things. So we need to cast and make things very specific so that Python can say, hey, this one's an int, and that one's an int. Now let's add them together. So let's do, finally here, we've got a string to int addition, right? So if I'm adding, again, if I'm adding the label to begin with, what's inside of the print function needs to be of a single type, In this case, since we're adding a string label, we want to have everything else be a string too. So this might be a little difficult to read, but the deal is we're turning everything that's in int 100 the string turned into 100 the integer plus 50 the integer. We want to turn that into a string and add it to the label. Let's see if that works. And so now we have a label at the beginning and we have 150. So that's cool. Does that make sense? That's the basic idea of the do now. We start off with integers, we turn them into strings, and we play back and forth with those. If we're going to add a string, anything that happens within the middle of this print command needs to be of the same type. So again, we can print the two integers added together because another integer comes out, and then the print statement will turn the integer into a string by default. But the arithmetic is where we get into trouble. If we try to add something that doesn't work, like here, we're going to blow up. Remember, again, here's a string as a label, and we're adding the string, to very specific ints, right? And Python, again, looks in the box, doesn't look in the box, looks at the box and says, this one's a string, this one's an int, now I'm going to blow up. Okay, cool. So one of the things you need to do for your lab and in the future is to be able to take numbers and be able to turn them in, to be able to deal with them, right? To take input from the user, and we talked about using the input function, and now we get a text from the fam. So we take a number from the user with the input, and the number is going to be a string. Now, this is the complicated part. I'm going to use a try catch, and we haven't really done this yet. But the thing is that someone can give you a number. You always have to be defensive when you write programs so that you expect bad data from your user. Your user is always going to give you bad data. No matter how careful you are with your instructions, someone's going to come in here and do something funky. So the first thing I do is I say, give me a number. Now we're going to hope that this person gives me a number that can be turned into a float. You remember when we talked about casting, taking a value from a box and through a function, turning it into something in a different box. In this case, we've got a string from the input, and what we want to do is turn that into a float. So what we're going to do is use the float cast to float it into here. Now, that can fail. Let's see when it fails. So someone says, give me a number. What if I type in 5? Well, 5 is going to blow up. That's no number. So this is Mr. T approved error messages. So this try says, what happens in the indented part below might screw up. Try it, and let's see what happens. If something breaks, try it, unless, of course, you get this value error. If you get a value error, then we're going to print out that what you said was no good. So in a given number, if we type in something that doesn't cast into a float, we'll jump down to here. But let's pretend, and for the purposes of what you're writing, you can just write straight up, the float is equal to, and then cast it and pretend that there's not going to be a mistake. But let's go ahead and try it again. So let's give a number, and let's get 12.34. Okay? And so I've got a string from here in the number. I turn it into a float by casting it. Remember, a float is something that can have a percentage after it, or a decimal value. Floats, as opposed to integers are counting numbers plus 0 and the negative version of counting numbers, but they can't have a decimal after. The float can have the decimal, and in this case, I'm adding 5 to the float, and then I'm going to turn that answer, the answer, into a string so that I can print it out easily. So here's where I'm casting the float into a string. So I get a string from the user, I turn it by casting into a float, then I add some value to it and get another answer, and then I use another cast string to be able to print it out. Does that make sense? And that's basically all we're looking at doing, I think, later in some labs. You could also do an integer value or an integer version of this, and that's what I have over here. So the same thing, give me an integer, and we can do the int, and we can try it, and if the value error pops up and it says that wasn't an integer, we can print out a Mr. T approved, that ain't no integer fool error message. So we can try this, give me an integer, and if I do what I did before and give it a float, it's going to blow up because that's not an integer. But if I do give it an integer, it's going to be happy, it's going to add 5, and it's going to give me an answer from it. And this is the same sort of thing going on, just notice that the casting is different. In this case, we've got an int cast. Okay, so anything else we need? What if we wanted to clean the output if we have an integer result in the float answer. One thing that's interesting here, and what that comment is referring to, is if I gave a 5 here, it's going to give me 10.0. We could have some extra logic that check to see, is our float value after we've added stuff actually an integer? And if it is, we could clean it up and not do 0.0 if we wanted to be clean. But we'll save that for a future lesson. So I think that's pretty much all we need to do for the lesson part. What we're going to talk about here, remember casting again, and the metaphor I'm using for casting is that you have metal, you have a metal cast, you melt your metal down, you pour it into the cast, and then it looks like whatever the cast was. So, if you have a railing, you have a big railing cast, that's probably not what they usually use a cast for, but it would be a giant cast, you pour the metal into it, it cools down, and it turns the metal that looked like one thing into something else. And you could pull it out, you could melt it down, you have a cast that makes it look like a fender for a car, and you could turn that metal railing into a car fender, right? If once you've taken it and you've gone through and you made it malleable and you poured it into a different cast, it'll be something different. So, in your notebook, predict what these results will look like. So, if we're going to cast a float of the string 1, what's your prediction? And then when you type it in, let's see what it ends up being, right? And so create a program that will take an input and print out that input divided by 2. This is almost exactly what we were doing just a second ago when we were adding 5 to floats. So you want to take the input, you want to take a quick look at casting it. If it blows up, if you really want to be fancy, you can do a try catch. Otherwise, just expect that it's going to blow up if you get a bad value. And then you do whatever your operation is, and you can print the answer back out. So that's what today's lab is. And then you can also have your program have 2 modes, a float and integer mode. We talked about that a little too. That should be fun for you to do if you have nothing better to do while you're sitting around at home waiting to get back to school. All right, so I think that's it. And thank you for your time. And if you have any questions, I think Brian is going to be around in half an hour. And maybe he'll be around later this week too. Have a good one.